Hello and welcome to the presentation on 3D printing from Group F, which comprises of Alexandra Christoforetas, Gabriel Nakambra, Shannon Miles, Shruti Narala, and Abhishek Shrivastava. In this presentation, we will cover various topics starting with the overview of 3D printing, followed by its application in the real world. We will also talk about the brief history and timeline of development, followed by relevant IT components and costs involved in 3D printing. We will also cover the benefits of 3D printing, and lastly, the risk involved with along with the future trends will be discussed in this presentation. All right, so let's start with an overview of what is 3D printing actually. 3D printing essentially is a manufacturing process where a three-dimensional object is created layer by layer in accordance with the digital model 3D, which is actually a computer-aided design. There are a variety of 3D printing materials available, including thermoplastics such as acrylonitrile, butadiene, styrene, metals, resins, and ceramics. Using these materials, a very complicated design can be made in a very short span of time with very less cost. Let's talk about the applications of 3D printing in real world. In recent years, 3D printing has developed significantly and can now perform crucial roles in many applications, with the most common applications being manufacturing, medical, industrial, and socio-cultural applications, such as architecture, custom art, and design, and can vary from fully functional to purely aesthetic applications. Talking about manufacturing sector, there are various applications of 3D printing in manufacturing area. Let's talk about them one by one. Starting with the cloud-based additive manufacturing, which is combined with cloud computing technologies that allows to have a decentralized and geographically independent distributed production. Then there's the mass customization, in which companies have created the services where consumers can customize objects using simplified web-based customization software and order the resulting item as a 3D printed unique objects. Rapid manufacturing, it is a new method of manufacturing and many of its processes remain unproven. 3D printing is now entering that field of rapid manufacturing and was identified as a next level technology by many experts. Rapid prototyping is a group of techniques used to quickly fabricate a scale model or of a physical part or assembly using three-dimensional computer-aided design data. Construction of the part or assembly is usually done using 3D printing or additive layer manufacturing technology. 3D printing can also be very useful in research labs due to its abilities to make specialized bespoke geometries. Additive manufacturing of food is also being developed, which by squeezing out food layer by layer into three-dimensional objects using 3D printers. And the last part of agile tooling, it is a process of using modular means to design tooling that is produced by additive manufacturing or 3D printing methods to enable the quick prototyping and responses to tooling and fixture needs. Agile tooling uses a cost-effective and high-quality methods to quickly respond to customer and market needs. Coming to the medical applications of 3D printing, one of the major use has been in the field of bioprinting, which is an extension of traditional 3D printing. Bioprinting can produce living tissues, bones, blood vessels, and potentially whole organs for use in medical procedure, training, and testing. 3D printing for medical devices can range from human prosthetic applications to animal prostheses to medical machine tools. Additive manufacturing has been increasingly utilized by scientists in the pharmaceutical fields also. Talking about the industrial applications, 3D printing has entered the world of clothing and apparels, with fashion designers experimenting with 3D printed bikinis, shoes, and dresses. It is also used to manufacture molds for making jewelry and even the jewelry itself. In automotive industry also, 3D printing is being used to manufacture many components. 3D printing is being utilized by air forces now to print spare parts for their planes. 3D printing is also used in construction or home development or producing firearms and also making parts of computer and robots. It has found its place in the soft sensors and actuators manufacturing inspired by 4D printing concepts. Then there are applications of 3D printing which have a socio-cultural significance, such as art and jewelry or taking 3D selfies. Communication is another key area which is making use of additive manufacturing. There are domestic uses of 3D printing as well, where people are using 3D printer in their households to make ornamental objects or gears. Overall, 3D printing technologies has found usage in education and research areas as well, and for environmental purpose, and even in preserving cultural heritage and restoring them. So overall, there are some major uses and applications of 3D printers and the technologies. Is day by day it's getting more adopted and utilized in various fields and areas.
My name is Gabby, and I'm going to be going over a brief history of 3D printing. The concept of 3D printing dates back to the 1940s, when a sci fi writer named Murray Leinster dreamed of a machine that would use an arm to melt plastic to create a 3D object of his drawings. However, this dream would not become a reality until the 1980s. During this time, many tried to patent this technology and failed. Finally, in 1984, Charles Hull applied for a patent for a stereolithography system, which was approved in 1986. Just 2 years later, he released the first ever commercially available 3D printer. Because of this, he has been coined the father of 3D printing, and this technique is still used today. By the end of the 80s, other 3D printing technology was developed, including selective laser stinting, direct metal laser stinting, and fused deposition modeling. Throughout the 1990s and early 2000s, further developments and new tech decreased the cost of commercial units. In 2005, Z-Core launched a breakthrough product, which was the first ever high definition color 3D printer to hit the market. And just 3 years later, the first 3D printed prosthetic leg was created, which demonstrated the future capabilities of this technology.
Hi, this is Shruti. I'm going to talk about the relevant IT components of 3D printing. There are several methods in 3D printing. Few of them are additive manufacturing, rapid prototyping, subtractive process, stereolithography. Additive manufacturing or additive layer manufacturing is the industrial production name for 3D printing, a computer controlled process that creates three-dimensional objects by depositing materials, usually in layers. Using computer-aided design or 3D object scanners, additive manufacturing allows for the creation of objects with precise geometric shapes. These are built layer by layer, as with the 3D printing process, which is in contrast to traditional manufacturing that often requires machining or other techniques to remove surplus material. Rapid prototyping is the fast fabrication of a physical part, model, or assembly using 3D computer aided design. The creation of the part, model, or assembly is usually completed using additive manufacturing or more commonly known as 3D printing. In the separative process, a block of material is carved to produce the desired shape using milling, grinding, or turning. Stereolithography, which is a fast and affordable technique, was the first successful method of commercial 3D printing. It uses a bath of photosensitive liquid, which is solidified layer by layer using a computer controlled ultraviolet light. So, what is the difference between additive and subtractive manufacturing? In additive manufacturing, layer by layer material is added one over another to build desired solid 3D product, whereas in subtractive manufacturing, the material is gradually removed from a solid block. In additive manufacturing, complex shapes can be easily fabricated, whereas subtractive manufacturing process have limited ability in fabricating complex shapes. In additive manufacturing, no wastage of material takes place, whereas in subtractive process, more wastage is produced during carving in the form of chips, scraps, etc. There are various methods in which 3D models can be built. Few of them are using computer-aided design, manual modeling process, and 3D scanning. To perform a print, the machine reads the design from printable files called STL files. STL is a file format commonly used for 3D printing and computer-aided design. The name STL is an acronym that stands for stereolithography, a popular 3D printing technology. You might also hear it referred to as standard triangle language or standard tessellation language. The printer layers down the successive layers of liquid, powder, paper, or sheet material to build the model from a series of cross sections. Layers that correspond to the virtual cross sections from the CAD model are joined or automatically fused to create the final shape. Now, coming on to the type of printer, few of the popular printers are listed below. Stereolithography, which is also called as SLA, selective laser sintering, SLS, fusion deposition modeling, FDM. Coming on to stereolithography, SLA 3D printers use a laser to cure liquid resin into hardened plastic in a process called photopolymerization. Resin 3D printing is a great option for highly detailed prototypes requiring tight tolerances and smooth shapes, such as molds, patterns, and functional parts. SLA 3D printers are widely used in a range of industries from engineering and product design to manufacturing, dentistry, jewelry, model making, and education. Selective laser sintering 3D printers use a high power laser to sinter small particles of polymer powder into a solid structure. The unfused powder supports the part during printing and eliminates the need for dedicated support structures. This makes SLS ideal for complex geometries, including interior features, undercuts, thin walls, and negative features. Parts produced with SLS printing have excellent mechanical characteristics with stretch resembling from that of injection molded parts. Fusion deposition modeling, also known as fusion filament fabrication, is the most widely used type of 3D printing at the custom consumer level. FDM 3D printers work by extruding thermoplastic filaments such as acrylonitrile butadiene styrene polylactic acid through a heated nozzle, melting the material and applying the plastic layer by layer to build a platform. Each layer is laid down one at a time until the part is complete. FDM 3D printers are well suited for basic proof of concept models, as well as quick and low cost prototyping of simple parts, such as parts that might typically be machined. However, FDM has the lowest resolution and accuracy when compared to SLS or SLA, and is not the best option for printing complex designs or parts with intricate features. Higher quality finishes may be obtained through chemical and mechanical polishing processes. Industrial FDM 3D printers use soluble supports to mitigate some of these issues and offer a wide range of engineering thermoplastics, but they also come at a steeper price.
A 3D printer is a long-term investment for both individual consumer use and for the daily operations of large organizations. We'll explore the relevant costs involved, including the cost of the printer itself and the supporting costs, including materials, software, and energy. With such a wide range of uses, there are machines made with certain capabilities for every type of user, and priced as such. On this slide, we can see the 5 price tiers for the 3D printing industry and how the price varies by type of printer. For the at-home user who is just looking to get their feet wet and try out 3D printing, there are basic, low-cost 3D printing machines ranging from $100 to $400. with most beginners spending around $200 for their first machine. This is a low barrier for entry and allows many users to try out printing without the risk or burden of a wasted monetary investment if they do not end up pursuing 3D printing long term or if they don't plan to use it frequently. These machines will come as kits which the consumer will need to build themselves. The kits usually only include the printing hardware. This means while the price is low for the equipment, the modifications, repairs, and upgrades, which may be necessary to get the printer's capability up to print the desired piece, may be costly, as the products are highly susceptible to manufacturing problems. We'll cover this in more detail soon. The next tier is referred to the hobbyist tier because of the 3D printer capabilities, functionality, and the price range are all geared toward customers who enjoy spending time working with different settings on the machine, setting the machine up for different projects, and enjoy printing enough to continue using it long term. Hobbyist 3D printers come at a cost ranging from $400 to $1,000. The increased price range from the tier below gives better product performance with less susceptibility to the manufacturing problems. This product still has an open design and requires assembly similar to the low-cost printer, but will produce better 3D prints and more complex designs than the low-cost printer is capable of. There are also some limitations with this model in regards to flexibility, as most machines can only use the polylactic acid, or PLA, filament for printing. The third tier is the enthusiast or prosumer 3D printer, which ranges from $1,000 to $3,000. The printers in this tier are known to be safer, more reliable, and low maintenance, making them a great long-term option for places like schools or for consumers who use 3D printing frequently for a production tool at home. The printers have a closed design, unlike the 3D printers in the previous two tiers. This makes the printers more safe to use and encloses all the moving parts, ensuring they do not accidentally get damaged from exposure, and increases the reliability and longevity of the machines. The price range here is higher than the previous two tiers because the machines are made with a higher quality design, so the user doesn't need to spend extra time on maintenance. These machines are also able to print an array of different materials and filaments with the same quality, but often must be refilled with the filament from the same brand as the printer. The fourth tier is the professional 3D printer, at a price of $3,000 to $10,000. The professional tier really separates itself from the casual user to the skilled user. The printers in this tier are designed with engineers and designers in mind, with capabilities to meet their needs. The professional tier 3D printers have synchronization functionality and can run unsupervised. This means you can start printing a project on one machine and sync other printers in different locations to print the same part at the same time. Additionally, if the desired print is complex and expected to take some time, the machine can continue printing overnight or through the weekend to meet the product deadline without risking safety or quality. As such, the capability of these printers is significantly greater than the previous tiers, and the machines are actually the easiest to use thus far in regards to user experience. With these machines being designed for a target market of engineers, the machines have capabilities to print using engineering-grade materials such as build or support materials, as well as printing with reinforced carbon fiber or metal embedded in the print. All in all, these printers are priced for the professional and provide a greater degree of flexibility in design and material, more reliability, as well as an easier user interface for maximum productivity. Finally, we have the fifth tier, which is the industrial 3D printer, priced at $10,000 and up to hundreds of thousands of dollars. Unlike all the previous printer tiers, these printers are specially designed to produce only a few products, but each item produced is of the highest quality and very precise. For example, it could print a replacement piece for a part of a car. These machines also have technology with the ability to print with high temperature polymers and metal materials. These are the most powerful 3D printers, printing with the most accuracy and speed, and having the most reliability, which is what the higher cost is derived from. While the cost for 3D printers can range above $10,000, the market average is actually around $400, as the category of printers with the highest volume sold is the low-cost 3D printers. Upkeep of 3D printing is very economical. The cost of energy used in production for 3D printing is roughly $50 per year for the average 3D printer. The material is the biggest cost in the long run for 3D printing, as it is essential for the production process and is recurring over the course of the printer's lifetime, similar to the cost of gas for a car. For fused filament fabrication, 3D printing, which is the most common in the market, the cost is approximately $20 to $50 per kilogram, and $60 to $120 for specialized engineering and support filament. Stereolithography filament costs around $50 per liter. Professional printing materials around $150 to $400 per liter. Selective laser sintering powder costs around $100 and $200 per kilogram. Most 3D printers come with basic software for operating the machines for free, but functionality of this software is limited. Additional software can be purchased, with most plans ranging from $50 to $1,000 per month, providing added features including support, training, and cloud storage for designs. 3D printing is becoming an increasingly popular production method due to the many benefits it provides in all aspects, from design capabilities to cost and efficiency. One benefit is the flexibility it provides in design, as 3D printing is a different production process compared with traditional manufacturing. This means 3D printers can create more complex designs, as there aren't as many restrictions with 3D printing as there are in traditional methods. Additionally, 3D printing mainly uses plastics as the material, which is lightweight and strong compared to other traditional building materials, which are very heavy. From an environmental perspective, the lightweight nature of the materials provides benefits such as improved fuel efficiency when 3D printing is used for parts of a car, for example, compared to traditional heavy materials. Additionally, there is very little waste, meaning all the material input into the build is actually included as part of the final product. Comparatively, traditional manufacturing processes cut pieces from large chunks of material and discard the remaining unused materials. This material saving trait of 3D printing reduces the production costs. 3D printing also presents many cost benefits. 3D printing is a single-step manufacturing process, meaning only one machine is needed, and no third-party manufacturers or outside parties are needed to be included in the production process. Additionally, printers can continue working while unattended or overnight, reducing the cost of labor. Because 3D printers are becoming readily accessible, there are more machines in the market, and therefore more local 3D printing service providers who are able to manufacture items for other businesses or individuals. The localization of 3D printing drives down transportation costs for those using the service, as shipping costs are reduced by local pickup options. compared to purchasing a piece manufactured and shipped in a different country. This also saves time, as the desired piece could likely be printed and picked up in the same day, or even within a few hours. Because 3D printing also is able to print manufacturing parts quickly, this can help engineers and investors create prototypes at a faster rate, which allows the design process as a whole to be faster, as modifications can be identified, created, and retested efficiently. 3D printing can also be done at any time, allowing users to print any design on demand. In regards to real estate and space, on-demand printing allows organizations to print exactly what they need when they need it, removing the need to create large inventory stockpiles and warehouses. Furthermore, the designs themselves are kept in a virtual library and can be easily accessed and printed at any location without having to bring a physical copy to the location for replication. 3D printing is not limited to construction or automotive build design. 3D printing is actually being used in healthcare to print organs for humans, such as livers, kidneys, and hearts, which are being used to save lives. While these benefits make 3D printing very enticing, it's also important to be aware of the risks and drawbacks of the industry. One drawback is the limited materials available for printing. While printing can be done with a wide range of plastics, metals, and carbon fibers, there is still a limited array of materials in each of these categories that can be used for printing. Many materials cannot be temperature controlled at the level required to print successfully, and further, many of the materials that can be used for printing are not safe for use with food, limiting the designs that can be made with them, such as bowls, plates, or utensils. Many of the materials that can be used for printing are not environmentally friendly, as they cannot be recycled. Additionally, 3D printing designs can be printed inaccurately due to certain machines and materials having a lower tolerance than required for the desired design. This means certain materials cannot be manipulated by the machines in the way needed to produce the desired design. As such, the malleability of the materials hinders the design functionality. Another drawback for 3D printing is the physical printing capabilities and process. Many 3D printers have small printing areas, which limits the size of the prints. As such, many parts must be printed in pieces and connected together manually after printing is complete. This leads to increased production time and labor costs. Additionally, the actual printing of the design is done layer by layer. While this process ensures the product is cohesively joined together, it also presents the risk that the product can be divided into layers if the materials are under stress due to misconfiguration in the design settings. Furthermore, printing is not always clean cut, meaning the product will need to be refurbished to get a smooth finish and remove the excess support materials. This is done many ways, including water jetting, sanding, chemical soak and rinse, or air heat drying. This further limits the overall production speed of 3D printing and increases production costs. There are also some economic drawbacks and risks that are important to consider. First, 3D printing is a fixed cost, which means the cost per unit does not reduce as it would with traditional manufacturing methods. Also, with 3D printing being automated, there is a lack of need for human intervention. This means with many manufacturing jobs will be taken off the market, being replaced by printers and technology, increasing job scarcity and unemployment, which contributes negatively to the state of the economy. Lastly, there are certain copyright issues that arise from the accessibility and ease of 3D printing. As many 3D printing machines have become a commonality in regards to economical price points and machines being readily available, the opportunity for ownership is increasing abundantly. This accessibility to 3D printing means more people will be able to operate and create designs without regulations. As such, there is a risk of counterfeit products beginning to enter the market, as people can easily recreate copyright-protected designs and print them at the same quality as the original. As such, there are many risks involved with 3D printing.
Some of the future trends that we can expect for 3D printing is that it will continue to impact existing industries such as construction, food, and fashion, but it will also play a huge role in new emerging markets such as commercial space, drones, UAVs, robotics, and urban mobility. By using 3D printing, it will provide more opportunities for creativity in these new emerging markets, especially as 3D printing and AI become more heavily integrated, which will also cause machine learning to become a standard tool. There are new breakthroughs that are to be expected in the medical field, as new materials from 3D printing can help in drug discovery, the creation of tissues, and potentially one day it could even lead to transplantable human organs. Big pharma companies in the future will sell ink cartridges with drugs to prepare personalized medicines on demand that are easily accessible to patients, which will be a huge stepping stone in the health industry. We can also expect there to be an increased focus on sustainability throughout the production process of 3D printing. We must make sure that the materials and energy used throughout this production process do come from renewable sources, especially as 3D printing will become a key role in reversing global warming. 3D printing allows for on-demand local production, which can cut transportation emissions. It also allows for lower energy consumption, a reduction in waste, and can transition to plant-based materials. We can also expect that traditional manufacturing will be replaced by additive manufacturing, and automation will become a key player in 3D printing. Through automation, it will eliminate human error and provide for more efficiency in complex designs, ordering, and logistics systems, which in turn will also lead to less waste overall and contribute to sustainability. There will also be an increase in demand for skilled workers as technology continues to advance, and we'll need more people who are able to be up to date with this new manufacturing. In conclusion, 3D printing will become completely integrated into the value chain. Mass customization will become standard, and we will most likely continue to see advancements in 3D technology as more investments are made in the industry to increase speed and efficiency. So overall, we can only expect things to keep getting better in the world of 3D printing. Thank you for your time, and I hope you enjoy our presentation.